Problem 3, continue with problem 1 and 2, forecasting the progress of the 8-mile highway construction projects after 6 months. The previous problems, we assess the project at the certain date, after 2 months, after 4, and after 6 months. And now, after 6 months, we want to forecast what's going on with the time and cost. When are we likely to finish the work? How efficiently must we use our remaining resources? What is the project likely to cost? And will we be under or over budget? What will the remaining work cost? And also ask us to develop baseline PV, EV unvalue, and AC's curve as of 6 months, and forecast the project time, forecasts, and costs at completion. So that is the problem we want to do. Before we get into detail, I want to go to the PowerPoint that highlight some information that we can visual with this problem. So this chart show you what we did in problem 2, and now go to the problem 3, which is the current lesson video. In terms of the time wise, we have 3 questions, and what are the measures that we use? As you can see there, are we ahead or behind schedule? We use SV. How efficiently are we using our time? SPI. When are we likely to finish the work? It will use time estimate at completion, EACT. How are we doing cost wise? So talk about costs. Then we have, are we under or over budget? CV. How efficiently are we using our resources? CPI. How efficiently must we use our remaining resources to ensure the project on budget? So that it TCPI, to complete performance index, not cost performance index, but it to complete. What is the project likely to cost? That is EAC, estimate at completion. Will we be over or under budget? VAC, variance at completion. What will the remaining work cost? That is ETC, estimate to complete. And we have equation for that as well for different time of equation, the variance, indices, and the equation. This also available in your exam 3 references. I will refer to in a minute. But now we say the in this problem asks us to develop the baseline, which is the planned value, and the unvalue and actual cost after as of 6 months. So as you can see, that is the budget at completion. So the at any given point in there, that is the planned value. So any given point you have here, that is a PV, right? Planned value. The total planned value is equal to budget performance, budget at completion. So that PV, and then we have contingency in the real life, and you did that in a problem in project 1. We put contingency to ensure to capture some uncertainty in the future that the project may face and may have problem with the cost and schedule. And then at the present time, let we erase that here, clear marking. At this present time, so we have that is PV at that, and then we have the be able to determine the N value, and in this case the N value is below PV, so the difference EV minus PV negative is mean that the project behind schedule. So we plan to do the PV, but we earn less, so that it about the schedule. The difference between that, talk about the schedule, and then we can forecast what we are our progress, and that will be somewhere here, so that we can estimate the delays of the project. So between the EV and PV, we can do the delay, and then we can have the actual costs, and in this case the AC, and then we can be able to determine the variance between the EV and AC to see the project is over or under budget. In this case, the AC is greater than on above the earn value, so you earn less than you spend at any given point, and you can see this is AC at this point, and this is EV at this point. So your actual cost is greater than what you earn, so you are over budget. So that what you have, and forecast what you will have in the over budget in that one. So with that one, let me go back to the problem, and then we can be able to do this. So when are we likely to finish work? So we talk about the time wise, and if you see the PowerPoint that I just showed you, that will use the time estimate at completion, a estimate at completion, but because the EIC stands for the cost already, so to differentiate time we put T in there. Let's put T lowercase, so time estimate at completion. For the equation, it equal to the budget at completion divided by SPI, and in this case the SPI 6 because at of 6 months, so you use SPI 6 divided by the budget at completion times the time T, the total completion. And with that, as SPI 6 from problem 2, we have SPI, if you recall that, the SPI equal to, for 6, SPI 6 equal to 0.83 and CPI 6.75, and this is the number for PV, EV, and AC from problem 1 and problem 2. So that we can have BAC 12 millions, if you remember that is 12 million given in problem 1. SPI 6, like I say, it equal to 0.83 divided by the BAC, that is also 12 million, divided by the time, 8 months, that is the total for this project, and you get that is equal to 9.6 months. So originally we plan to finish this project is 8 months, but at of 6 months with the current progress, we anticipate that project finish 9.6 months with a delayed 1.6 months. So that's what you have for the likely finish the work. How efficiently must we use our remaining resources? So cost-wise, to use that, if you remember the slide, go back to check that slide, and the equation to use is 2 complete performance index, 2 TCPI, 2 complete performance index. And from the equation in your reference, we also have that as well. 2 complete performance index is equal to BAC minus EV over BAC minus AC, and you have equation there as well. So all equation here in your reference. So from there we can have equal to BAC and at 6 months, so BAC minus EV 6 divide BAC minus actual cost 6, so it will be 12 million. EV6 equal to 7.5 million from problem 2, and this one is from 12 million. AC6 10 million from problem 2, and that we have 2.25 ratio dimensionless. What does that mean for this one? How efficiently we are using our remaining resources, and that number is 2.25. What does that mean? It means that for a project to achieve the budget, which is the budget of completion, 12 million, to make sure the project on budget, 12 million within budget, the performance must be improved from the CPI of 0.75, that is at 6 months, to a TCPI of 2.25 for the performance of the remaining works. It means that now, because we are not efficient in the first 6 months to achieve the project, every dollar you spend now, you have to earn $2 and a quarter, and you see that unbelievable. It cannot be achieved. Spend $1, you earn $2 and a quarter. So you see how realistic it is in there. So this project is likely to be over budget. So unless like CPI and TPI, this one, the greater this index, to complete performance index, greater the cost. So you want something less than 1. If it's 1, it's good enough, but something less than 1, even perfect. But it 2 or something, that is very challenging to print the project on budget. So that B. C, what is the project likely to cost? So it will be estimate at completion, and the equation from us is estimate of BAC minus over CPI. So we have it BAC over CPI as of 6 months. So we put 6. So it's 12 million divided by 0.75 from problem 2. So we have it 16 million. So it means that the budget is 12 million, but most likely this project going to cost 16 million. Will we be under or over budget? So that is we use the variance at completion. So go to the here definition on of that in the page number 1. VAC, variance at completion. You also see that in VAC, and the variation at completion is equal to VAC, and VAC equal to BAC minus EAC. So you have that one here. VAC equal to BAC minus EAC. And BAC, budget of completion 12 million minus estimate of completion 16 million. So it will be negative 4 million. What does that mean? It is over budget 4 million. What does that mean here? Over budget 4 million, from 12 million to 16, so it's over budget. What will the remaining cost work? So estimate to complete. So it will be estimate to complete, and the equation is also in there. Estimate to complete etc BAC minus EV divided by CPI. So you can have that one. BAC minus EV earned value at of 6 months divided by the CPI at 6 months. So you have 12 million minus 7.5 million divided by CPI at 6 months. We have that equal to 0.75. Then we have it 16 million. So far after 6 months, we spent the actual cost. AC6 is 10 millions. We need 6 more millions to complete the project. So with that, we answer all the 5 questions and now develop the baseline PV, EV, and AC curve as of 6 months and forecast the time and cost at the completion. We already forecast there, but now we can put in the graphic, just like I show you in the report of the Edward Sport project. So with that one here, and this is the number I noted from problem 1 and problem 2 in today's lesson, so that we can have the number to work with. Then from that one, we can be able to draw the graphic. Yeah, and it will be month, and this it will be cost, in this case dollar in million. to month 9.6, so it's the 10, about 10, so we have that is 10, 2, 4, 6, 8. And the cost, the estimate at completion is 16 million. So we have 16 maximum in this 16. So let's divide that is the 16 million. So you can have the, or we can put AC here 2.5, 10. So we can put that everything is 3, maybe, okay, maybe 16, and then 8, then we have that is 12, and we have that is 4, 2, 6, 10, 14. Now we draw it as that we have nothing, and let's talk about the plan value. PV2 3 millions, 3 million. So we have that one 2 at month 2, 3 million, 3. So the plan value, I put that point there, 3 millions. 4, 6 million, and PV6 9 million. So 4, 6 million. And then 6, 9 million, 8, 10, 9 here. And similar, if we have 10 8th month, so 12 millions. 8th month, 12 millions. That is the plan complete. The capital is 8th month, and the cost is budget of completion equal to 12 million. So you can be able to put the baseline, go through all of these points, and that is PV after 6 months, and you can see 9 million. You have there 9 million, that is the 6 month. So years is the, if I put the like here, so that is status days after 6 months, and you can see that. So we can, and the total is the BAC. The total is BAC, which is the top there. Now do similar for the unvalue in 6 months. So EV2 3 million, 3 million. So EV2, I put that in. Let's select that in blue. 3 million. So it's the same. So we have 3 million there. 2 EV. So that is the PV. So let's put that one black line, PV, plan value, blue, unvalue, and then I will do the actual cost is red. 4, 4.5, 4, 4.5. So 4, 4.5. So you have 6 there, 5, 4.5. So 4.5. So that you will have the red, the blue one for unvalue, and then 6, 7.5, 6, 7.5. So you 8. You have 7 and 7.5. There. So we have that point. So we could go ahead to draw down now, and that blue equal to earned value. And then we have actual costs. 2 million at 2. So 2 million. So you have the first red. 4 months, 5 million. So we have the 4 months, 5 million. You see 4, 5 here. That number. And then 6 months, 10 millions. 6 months, 10 million. So we have there. And that is the actual cost. So that what you have for the cost in terms of earned value, planned value, and actual cost. And now we can forecast what happened in the future. And our future here is we estimate it 9.6 months to complete, as you can see there. So 9.6 in here, we have that is the our estimate time. Let's put that 9.6 or 9.6 there. 9.6 months. So that is what we expect the project to complete. And to complete that, the cost estimate of completion is 16 months. So you can have that one is 16 months. Go to there. Then we can be able to forecast what is the final cost look like. If we do at bad at the before, so we can complete the project in 9.6 months. And it because we forecast, so it in dash line, and it needs $16 million. And what will we earn? Of course, you cannot earn more than the contract cost for unless the change. So what does that mean? Instead of we earn 12 millions after 8 months with the what we plan, but it actually we will not earn that much until 9.6 months. So that is the that what we have. So with that, we done for problem 3 in today's class. In problem 4, you will watch the video and with the use the software to do. But that is problem 3. Answer all the questions and develop the curve to show the progress of the project.